at some 2012 questions today. In 2012, first question dealt with this thing called the ClimbInfo. All right, so here we are again. It's a user-defined class, something they made up. So you got to ask yourself, what can it do? And if you've seen that phrase now a few times, methods and control structures, that's something that is advertised, will be present in both of our free response questions this year. This is exactly what they're talking about. When they talk about methods and control structures, they're saying, can you call methods? Can you satisfy parameters? Do you understand return types? Can you construct an object from a constructor? That's important. That means you're going to have to use the keyword new. Okay, so you can count on those things showing up on your AP exam. You know, do we like using the keyword new? I don't know. I mean, I know that's something that we struggled with a lot in class, but we're going to have to. And the reason we're going to have to in this problem is because we're going to write two add methods where we're expected to add into an array list called ClimbList. This array list holds ClimbInfo references, and that's it. So you can't put strings in here. You can't put ints in here. If you want to put something into this list, if you want to add to this list, it must be encapsulated as a ClimbInfo object. Okay. The only way that we can get a ClimbInfo object, unless one is handed to us, is to use the constructor of the ClimbInfo class and make one. That constructor demands in order a string and an int. Okay. They give us the string and the int. We have to take that string and int and make a ClimbInfo object out of it before we can add it to this array list. How do I know that? Well, because that's the type of the array list. Whatever that type is the type of object that is allowed to enter it. It's also what would come out of it if we were to get something from this list. Okay, it would come to us as a ClimbInfo. If we had a ClimbInfo, we could either ask for its name or its time, and we may have to do that in part B. But in part A, it's actually pretty easy. You just add these ClimbInfos in the order that they come to you. So the later that you add them, the later in the list they go. And remember, the default add method of array list simply adds to the end of any list. Okay, so part A is pretty easy. It's a void method. We don't really need to return anything. You could actually do this in one line of code. I'll do two just to kind of highlight the process. So first I'm going to declare that I have a ClimbInfo object. Okay, I named it climb, and it's a new ClimbInfo. So again, I'm going to the constructor. I have to use the word new. It demands from me in order a string. Okay, that's peak name, and an int, and that's climb time. If I hand those two things to the constructor will do its job and it'll make a new ClimbInfo. I don't know the exact way it does it. I don't really care. And then I'll take ClimbList. Again, make sure you're using correct variable names. And that was the name of the array list handed to this class, okay, or the instance field, I shouldn't say handed to, that belongs to this class. And then we're going to say ClimbList.add climb. And I could have done that in one line of code. I could have just put the new ClimbInfo straight in for climb. For part A, that's it. So like I said, it could actually just be a one-line answer. Okay, probably just like 2 points, I imagine, on the rubric. Okay. Part B is a little tougher. We have to keep these in alphabetical order as they enter the list. Few things, we get to assume that the list is already alphabetized as it comes to us. And we're not worried about like case sensitivity here. So we're just going across with like a typical compare to method. Okay, so alphabetical order as determined by the compare to method. So we're not worried about any case sensitivity here at all. Okay, so insert to the first available slot would be my recommendation. So imagine we don't know how many ClimbInfos are in this list. There might be 100, might be 5, it could even be 0, and that's actually going to be probably a special case for us because if there's 0 climbs in there, your climb would automatically become first and should just be added to the list, period. Okay, you don't even need an index at that point. Otherwise, when we add into this list, we're going to want to figure out like where does it go. They also mentioned that like ties don't matter, so like If there's two by the same name, you can interchange them. You don't have to like break the tie with the climb time or anything like that. Now, when I say alphabetically first, consider these two cases I put down here. Let's say that your current list is A, B, D. Where would you add the letter C? Like to what index would you add it to? Okay, hopefully you said 2, because if we put that C into index 2, 0, 1, 2, the D would move over to the right and make room for it. One way we could write this code, consider, is first ask the question, does C come before A? No. So move on to the next index. Does C come before B? No. So move on to the next index. Does C come before D? Yes, it does. Therefore, it would insert itself into that index. That's what I mean by first available. The first time that we see that we can say that this incoming string has a compare to value that's negative, if I were to do C compared to D, then that's where I should put it into the list. Okay. Now you got to be careful. There's sort of a trick here. What if we walked all the way across this list and we never inserted the item? Then we should insert it at the very end. That's probably going to be like a special case. So there's a few ways we could handle this. We could have maybe like, because we did one like this the other day, but it was a return method. So once we insert it, we shut down the method. Today's a little bit different. This is a void method, so we won't have a way to shut it down. We could set up like a Boolean tracker variable that tells us at the end of the loop whether or not the item was inserted. And we could then control the loop. So that another problem here is your loop might mistakenly like keep inserting that same string, that climb info, over and over and over. Because as this D starts to move right, then if your loop kept running, then the C might insert itself again in front of the letter D, and again and again and again. You might end up with like an infinite number of C's. So just like we have to be careful with the remove method in an array list, we also have to be careful with the add method because of the dynamic capability of an array list. It could keep changing as the problem progresses. So like I said, there's a few ways we can handle this. I'm going to show you the easiest way to do it first. It's not something that we commonly do, but it's the easiest way to handle it. And then maybe we can look at like some other ideas also. All right, so just like before, you might want to just consider making a climb info. Okay. Now there's a few things to consider. One is if the list size is 0, okay, then we're just going to simply add this thing in there, and then we're done. And if we did this again, it's like it'd be nice if we had a way to return. We actually do have a way to return. I'll show you in just a minute. But like if the size list was 0, then we could just simply say climb list dot add climb. Now I'd like the method to shut down at that point, but let's just keep writing code and see what happens. All right, if it's not that type of case, so we could put the word else here. If it's not that type of case, then like I was showing in that example, we're going to start looping across. Okay, and I'm going to loop starting at index 0. That's the first place that I might insert this climb. I'm going to go all the way across the climb list. Okay, dot size, and then I++. All right, so now, how do I know if it comes in? Well, if this peak name, okay, dot compare to, now this is where it gets a little bit tricky. When I get something from the climb list, okay, use the array list get method, that's not a string. That's a climb info object. But remember, climb info objects have names. You can ask for them. There's a get name method that you can use on any climb info object. So I can get the name of this climb. I'm looking for something that comes back to me as a negative number. Okay. Why negative? compare to works. So like if this starts with the letter A and this starts with the letter B, B's bigger than A, right? Like think of the ASCII code, 65 versus 66. It would come back as a negative number, okay? Any negative number there, and I have found a place in this array list where my peak will fit in there. So what I would do at that point is I would go ahead and add this. Now I'm gonna brace this if, because like I said, we have to have some sort of action to shut this process down. If we don't, it's just gonna keep adding itself. Also, remember this time we're gonna add at a particular index. So we're gonna add at index I, so that we take over that index. And remember, everything then would move over to the right. And that's kind of the problem. If everything started moving over to the right, if our loop kept going now, we would actually insert this climb again, because the one that we just put it in front of actually moved to the right. Our loop would move to the right. We'd make the same comparison, and we'd insert this again, and it would be endless. So one thing you can do here is you can use the keyword return, but it's a void method. So you actually just say, I'm going to return nothing. And what that does is that just shuts down the method. It's like a break, but it's a little bit more powerful. It doesn't actually just break you out of the loop. It actually just breaks you out of the entire method. And it just immediately shuts it down and stops it. I don't really need it here. If I had a zero list, I would have compared the same climb to itself. I would have gotten 0. So it wouldn't have like mistakenly done anything there. Okay, so like that should be totally fine. Now, I was saying there's another scenario here too. What if we come out of this loop and we haven't hit this return yet? Like, so we haven't shut down the method. If that were to happen, that would mean that our climb never got added to the list. And so I'd have to add it now, and I'd want to add it in at specifically climb list size. That's the very end of the list. And you're allowed to do that. You can always go one past that last index in an array list. It will make room for it, and it will put it in there. So this is a little bit weird. We maybe did that like once or twice in class was all. It's not a common thing, but you could actually return from there. So let's see, should look like either of these, and yeah, it looks like the second one. Okay, and then in part A, yeah, that looks good. I'll talk about that distinct peak names in just a minute. All right, let's say you didn't know how to do that return there. Then like what could you have done? Well, one way would be to make like a Boolean flag variable. For example, I could say something like added and say false, okay? And then in my control expression, I could make it like a 2-part control. So I could say not added and I'm still in bounds. So I only want to run the loop if my index is in bounds and I haven't added anything yet to the array list. Now, then if my if statement happened here and I added a climb into the climb list, I would flip added to true. That would break me from the loop, and then I would protect this with that same piece of code. And I would say if not added, okay, so it would have to be false still to become true, then I would go ahead and add this climb list here. So this should do 2 things. This should prevent me from getting stuck in an infinite loop, okay, where I keep adding the same climb over and over and over. And it should only allow in these climbs to the end of the list when appropriate here. So let's see what happens. Seems to be frozen right at the perfect time. sorry about that little delay, but yeah, it looks like it's working just fine still with that Boolean piece of code as opposed to using return. So like I said, if you didn't quite see what I was doing with that return, which is really weird to write return in a void method. But if you didn't like that, you could fall back on a Boolean variable. It's a little bit trickier. I had to adjust my control expression, and then I had to protect this statement with that Boolean to make sure I didn't add something twice. Because I only want to add to the list in a case where I walked through that whole loop and didn't add anything. But yeah, it is still working. And then just quickly on part C, it says that you should only do this. It's only supposed to count these peak names that are unique. So like that one climb in there, Monadnock, I think that's like a hill in Vermont or something. It shouldn't show up twice. The thing about this comparison is it's only comparing names that are adjacent to each other. So it wouldn't have worked in part A, because if you remember the list we generated in part A, Monadnock was not next to Monadnock in the array list. So their code wouldn't actually notice that it was comparing the same name, and so it wouldn't work in part A. But since part B is alphabetized, anytime we have the same name in an array list more than once, it would be adjacent to itself, and so we wouldn't count multiple occurrences. So basically, the kids that took this test, they were supposed to circle no for number 1. It doesn't always work in part A, and then circle yes in part 2. And we see that in the replit because it's showing that there's 3 distinct names. So I ran their code, in my tester. So it worked in part B, because there's only 3 actual names there. Don't count Monadnock twice. And it said 4 in part A. That was wrong, but that's what the code would have produced since Monadnock was not next to itself. All right, pretty tough problem there, part B. I don't think I've ever seen another one where they had to write return that way. If I do, I'll share it with you. But I think other years when they've had add methods, I think they realized that maybe this was a little bit difficult. And so they've always made it like a Boolean return, which actually makes the problem a little easier, because then you can return and just shut it down and not worry about like creating an infinite loop. But it's something to think about. Anytime you're adding or removing from an array list, you got to think about what that dynamic capability is going to have, what kind of effect that's going to have on your loop progression. So very good lesson there. For that problem.